Too many question marks about this flight, and we were 20 bar low on ground spin start pressure. These words from Elon Musk reveal the critical decision point that stopped SpaceX's ambitious Starship Flight 8 mission in its tracks on March 3rd. Just minutes before what would have been another historic launch from Starbase in Boca Chica, Texas, SpaceX engineers faced a cascade of technical challenges that couldn't be resolved within the narrow launch window. The tension built as the countdown approached T-minus 42 seconds. SpaceX's launch team detected an issue with the Super Heavy booster, a problem significant enough to trigger an automatic hold. Engineers sprang into action, working through the complex systems that power the world's largest rocket. Just when it seemed the booster issue had been resolved, another technical anomaly emerged, this time with the Starship upper stage. The countdown briefly resumed before being halted again seconds later, rolling back to T-minus 4 seconds as the team fought against the clock. Ultimately, SpaceX made the tough but necessary call, standing down from today's flight test attempt. Starship team is determining the next best available opportunity to fly. This wasn't just any routine delay. Coming after January's Flight 7 mission that ended in failure approximately 8.5 minutes after launch, every precaution was essential. That previous mission had revealed an unexpected harmonic response during flight, creating excessive stress on propellant lines that led to leaks, fires in the aft attic section, and the shutdown of 5 of the 6 engines. In response, SpaceX had implemented multiple design changes, reinforcing critical hardware components, adjusting operational procedures, and installing new venting and gaseous nitrogen purge systems to reduce flammability in vulnerable sections. Now Musk's team faces another challenge, but one they're approaching with their trademark methodical problem solving. Best to destack, inspect both stages, and try again in a day or two. Welcome to Elon Musk 24 Hours. Let's dive right in. SpaceX's journey with Starship has never been about perfect launches. As Kate Tai, a SpaceX engineer and webcast host, put it, "We fly to learn, and we're learning a lot." This philosophy has been the cornerstone of SpaceX's development strategy, embracing failure as a pathway to innovation. The January 16th Flight 7 mission taught SpaceX critical lessons. When the massive rocket thundered off the Launchpad that day, few could have predicted that approximately 8.5 minutes into flight, mission control would lose contact with the vehicle. The post-flight investigation revealed something fascinating: an unexpected harmonic response, essentially vibrations at just the right frequency, had placed excessive stress on the propellant lines. These vibrations, similar to how a wine glass can shatter when exposed to its resonant frequency, created enough stress to cause leaks and fires in the aft attic section of Starship. The cascading effect led to the shutdown of 5 of the 6 Raptor engines in that section, making recovery impossible. SpaceX engineers, in their characteristic methodical approach, implemented multiple significant design changes in response. They reinforced critical hardware components to withstand these harmonic vibrations and adjusted operational procedures to reduce structural stress during flight. Perhaps most importantly, they installed new venting systems and a gaseous nitrogen purge system specifically designed to reduce the flammability of the attic section if another leak were to occur. The SpaceX timeline: when fast is normal? So what happens now after this latest delay? When will we see Starship attempt Flight 8 again? Looking at SpaceX's track record gives us valuable insights. The company has demonstrated 2 distinct patterns when dealing with Starship delays. For minor technical issues, SpaceX has shown remarkable turnaround times, sometimes launching again within 24 to 48 hours of a scrubbed attempt. The fact that Musk specifically mentioned a day or two for the next attempt suggests the team believes the pressure issue and other question marks can be resolved quickly. But SpaceX doesn't rush when safety or mission success is at stake. After the first ever full-stack Starship test flight in April 2023 ended in failure, the company took nearly 6 months before attempting Flight 2. This wasn't just about fixing technical issues. SpaceX also had to address regulatory requirements from the Federal Aviation Administration. Flight 2 in November 2023 showed progress, but still encountered problems that resulted in early mission termination. Yet SpaceX's analysis and development cycle had accelerated. They were ready for Flight 3 just over 2 months later. The ground spin start pressure issue Musk identified, being 20 bar below the required threshold, relates to how the Raptor engines are initialized for ignition. This pressurization system is crucial for ensuring the turbopumps that feed propellant to the engines start properly. Being 20 bar low represents approximately a 10% pressure deficit from optimal starting conditions, significant enough to warrant caution, but likely fixable without major hardware changes. Behind the scenes, the destack process. When Musk says they need to destack, inspect both stages, this isn't a simple procedure. The Starship vehicle stands nearly 400 feet tall when fully stacked. The destacking process involves carefully separating the Starship upper stage from the Super Heavy booster using the massive chopstick arms of the launch tower. Once separated, both stages will undergo thorough inspections. Engineers will likely focus on the pressurization systems for the Raptor engines, particularly the ground support equipment that provides the initial pressure for engine spin-up. They'll also examine the unspecified issue with the Starship upper stage that emerged during the countdown. This process involves dozens of engineers working around the clock, reviewing data from thousands of sensors, physically inspecting components, and running diagnostic tests on critical systems. SpaceX's advantage is their vertical integration. They design, build, and operate their own hardware, allowing them to quickly implement changes without navigating complex supply chains or contractor relationships. The bigger picture, SpaceX's ambitious Florida expansion. While working to resolve these immediate technical challenges in Texas, SpaceX is simultaneously executing an ambitious plan to expand Starship production and launch capabilities to Florida. This expansion represents a significant evolution in SpaceX's approach to scaling Starship operations. The centerpiece of this expansion is the construction of a massive Starship integration facility at Kennedy Space Center, known as Giga Bay. This facility will stand approximately 115 meters tall, taller than the Statue of Liberty, and will revolutionize SpaceX's manufacturing capabilities. Giga Bay will contain 24 work cells dedicated to vehicle integration and maintenance, nearly 5 times the capacity of the current Mega Bay facility at Starbase, which has only 5 work cells. This dramatic increase in production capacity reflects SpaceX's confidence in Starship's future and their commitment to achieving a high launch cadence. SpaceX has set an ambitious target to complete the Giga Bay facility by the end of 2026. But they're not stopping there. A second Giga Bay is planned for Starbase with the same completion timeline, effectively creating a bi-coastal Starship production network. In the interim period, SpaceX plans to transport Starship vehicles from Texas to Florida until both Giga Bay facilities and additional manufacturing infrastructure are fully operational. This transcontinental logistics operation will allow SpaceX to maintain launch operations while building out their long-term production capacity. Historic launch sites getting a Starship upgrade. The Florida expansion extends beyond manufacturing to include launch infrastructure development. SpaceX is preparing Launch Complex 39A at Kennedy Space Center, the same pad that hosted Apollo missions to the Moon and Space Shuttle launches, for Starship operations. The launch tower at 39A has already been constructed, looming over the historic site where Neil Armstrong and Buzz Aldrin began their journey to the Moon. In the coming months, SpaceX will install a specialized deflector system designed to provide water cooling and sound suppression during Starship launches. With regulatory approvals and construction proceeding on schedule, SpaceX estimates that the first Starship launch from Florida could occur as early as late 2025. This would mark a significant milestone in the company's strategy to establish multiple launch sites for its next-generation vehicle. But SpaceX isn't limiting itself to a single Florida launch site. The company is actively exploring the potential use of Space Launch Complex 37, SLC-37, at Cape Canaveral Space Force Station as a second Starship launch location. This pad, most recently used by United Launch Alliance's now retired Delta IV rocket, could provide additional capacity for Starship's ambitious launch schedule. SpaceX has been granted limited access to SLC-37 to conduct feasibility assessments, and is participating in an ongoing environmental review process led by the U.S. Department of the Air Force. This environmental study, which began a year ago, is expected to produce a draft environmental impact statement this spring for public comment, with a final decision anticipated in fall 2025. The rapid iteration philosophy. Through all these developments, whether addressing immediate technical issues or planning long-term infrastructure, SpaceX maintains its core philosophy of rapid iteration. As Musk has frequently stated, the best part is no part, the best process is no process. This approach isn't about cutting corners. It's about removing unnecessary complexity and learning through real-world testing rather than extended theoretical analysis. When components fail during a test flight, SpaceX engineers don't just fix the immediate problem, they redesign systems to be more robust, more efficient, and more reliable. The delay of Flight 8 is just another data point in this iterative process. Each scrubbed launch, each technical issue, and each design change brings Starship closer to achieving its ultimate goal, becoming a fully reusable launch system capable of delivering large payloads to the Moon, Mars, and beyond. For SpaceX, this isn't just about bragging rights or setting records. The company has concrete contracts that depend on Starship's success, including NASA's Artemis program, which will use a modified Starship as the human landing system to return astronauts to the lunar surface. As we await the next launch attempt for Flight 8, it's worth remembering that what looks like a setback from the outside is often just another step in SpaceX's methodical march toward making humanity multiplanetary. Every canceled countdown, every technical issue discovered before ignition rather than during flight, and every engineering solution implemented represents progress in SpaceX's book. As Starship Flight 8 awaits its next launch window, one thing remains clear. SpaceX's journey to revolutionize space travel continues regardless of temporary setbacks. Each delay, each technical hurdle, and each design improvement brings humanity one step closer to becoming a multiplanetary species. The pressure issue that Musk identified doesn't represent a fundamental flaw in Starship's design, but rather an opportunity for the SpaceX team to ensure all systems are performing at their peak before pushing the boundaries of what's possible in spaceflight. While we wait for the next launch attempt, SpaceX's ambitious expansion plans in Florida demonstrate the company's unwavering commitment to scaling Starship operations. From the massive Giga Bay facilities to the historic Launchpads being transformed for Starship, we're witnessing the infrastructure of humanity's multiplanetary future being built in real time. As Kate Tai wisely noted, we fly to learn, and we're learning a lot. This philosophy, embracing failure as a pathway to success, continues to drive SpaceX forward, even when the countdown clock stops. If you want to stay updated on all the latest developments with SpaceX, Starship, and everything Elon Musk is working on, make sure to subscribe to Elon Musk 24 Hours. Hit that like button if you found this breakdown insightful, share it with fellow space enthusiasts, and let me know in the comments what aspects of the Starship program you're most excited about. What do you think will be the key technical challenge SpaceX needs to overcome for Starship's complete reusability? Drop your thoughts below. I read every comment. Thanks for watching, and I'll see you in the next one with all the latest SpaceX developments as they happen.